Assalamualaikum and hello. Let's get on to the continuation from our previous video where so far we've learned about Avogadro's constant. And in this video, I'm going to focus about molar mass. So, what is the definition for molar mass? Molar mass is the mass of 1 mole of an element or the mass of 1 mole of compound. And itu yang kita refers kepada molar mass. And for your understanding, molar mass mempunyai unit. So it has unit where the unit is gram per mole. So where does the units comes from? The unit comes from when you have mass. Usually in chemistry, mass we use in unit gram. But right now, the molar mass is referring to 1 mole. So that's why that mass in gram is referring to 1 mole of any elements or compound. That's why unit dia akan jadi gram per mole. And to do the relationship between mole with mass, we can use molar mass in our calculation. And I introduce to you this formula where di mana memang awak selalu nampak formula ini waktu awak belajar di level SPM. So this is the formula where you want to find out the number of mole. That formula is equal to mass in gram over molar mass in gram per mole. So, bila awak cancel out the units, gram, and per mole, bila dia naik atas, dia akan jadi mole kuasa 1. And it's just the same thing as mole. So, that's why when you calculate the number of mole, the unit must be abbreviated as mole. Now, I'm going to tell you one tip where the molar mass of any substance is numerically equal to its relative mass. And there are few terms that you can see or you can read throughout the course when you answer the question. So, molar mass sebenarnya dia mempunyai value yang sama dengan average atomic mass. And also, the value for the molar mass also equals to relative atomic mass. And the symbol for relative atomic mass that you've learned from the previous chapter is AR. And also, molar mass juga nilai dia sama, numerically equal with relative molecular mass. And in this term, biasanya kita gunakan sebagai MR. And the same thing as relative formula mass, also MR. So, what I'm going to say here, maksud numerically equal dekat sini, ia bermaksud nilai sahaja yang sama, tapi a few of them ada unit. So, maknanya contohnya, kalaulah awak punya relative molecular mass adalah 28. So, dia adalah relative sebab tu dia tak ada unit. Dia hanya ada nilai 28. But right now, I want to determine the molar mass. I know molar mass is numerically equal to the relative molecular mass. So, of course, the value 28 is going to be the same. But right now, what I want to say as my answer, the molar mass of that element is 28 gram per mole. Because molar mass hanya akan ambil nilai itu, tapi kita kena letak unit sebab kita faham molar mass mempunyai unit gram per mole. So itu yang dimaksudkan dengan numerically equal. So untuk lebih faham macam mana how it works, kita akan lihat contoh daripada example yang saya akan terangkan dalam page yang seterusnya. So mari kita lihat satu example di mana I got magnesium atom Mg, and how I want to calculate the relative atomic mass for Mg. The relative atomic mass for Mg is depends on the value that you got from the RAM table. So the RAM table, the value for mass for relative atomic mass for Mg is 24.0. And sebab dia relative, dia tiada unit. So bila dia tiada unit, you have to be careful. Just put the value only. The next one, kalau saya nak relate dengan mass of 1 mole Mg. So saya hanya nak mass untuk 1 mole of Mg atom. So my subject is mass, and as I mentioned before, mass must have unit. So maknanya must has unit. Unit untuk mass adalah gram. Tapi case ini, when I put in the previous slide, it's numerically equal, which means nilai dia sama, tapi kita hanya perlu tambah unit. So mass of 1 mole of Mg is going to be 24.0 gram. Okay, next one, I want to put determine the value for molar mass for Mg. So molar mass, as usual, it's numerically equal. So value dia equal, tapi unit dia berbeza. Dalam case ini molar mass, unit dia adalah 20 gram per mole. So value dia akan jadi 24.0 gram per mole. And one more thing, ini adalah based on 1 mole. 1 mole of Mg atom. So how you want to compare with the number of Mg atoms? You can say that for 1 mole of Mg atom, you will have 24 gram of magnesium atom, which is also equals to 6.02 exponent 23 Mg atoms. So ini adalah new kefahaman untuk awak. Okay, next one. I give you one more example. I got water. So, for water, the chemical formula is H2O. So, how you want to calculate the relative molecular mass for water? Relative molecular mass for water, Mr, is the summation for Ar. So, you have to add up all the relative atomic mass for H2O. So, you will get Mr is 18.0, as you can see here. And right now, I want mass of 1 mole of water. So, saya akan tambah saja unit gram dekat belakang. Nilai dia masih lagi sama. And now, I want to determine the molar mass of water. As usual, the value is still the same, but the unit is gram per mole. And last but not least, let's compare with the number of particles yang kita belajar sebelum ni. So, ini adalah untuk 1 mole of water. This is 1 mole of water where 1 mole of water we have 18.0 gram of water. In terms of molecules, I will have 6.02 exponent 23 H2O molecules. So this is in terms of number of molecules. So right now, I want to determine the value in terms of number of atoms. So number of atoms in water, I have 3 atoms. So which means that 3 times Avogadro's constant H atoms, H2O atoms. So this is the number of atoms. So nampak bila saya tambah pun saya tambah perkataan S dekat belakang untuk menunjukkan bilangan atoms yang lebih daripada 1. Okay, next one saya be specific. I want in terms of number of hydrogen atoms. So how many hydrogens in H2O? We got 2 here. So it means that Avogadro constant must be multiplied by 2 H atoms. So this value adalah value yang saya highlight warna hijau ni. Awak perlu write it down, final answer lah bila dalam awak punya worksheet. Untuk this slide, I just explain in a simple way for you to understand. Okay, last one, saya nak be specific in terms of number of oxygen atom. So, number of oxygen atom, as I said before, kita hanya ada satu sahaja oxygen atom dalam H2O. So, awak akan dapat nilai dia sama seperti Avogadro's constant. So itu adalah relationship tentang mole with molar mass dan juga how they are numerically same with the relative molecular mass, relative atomic mass. So in order for you to understand more about the relationship between them, I put the easiest way for you to memorize the formula. You can memorize this formula for your better understanding, ataupun kalau ada another way di mana awak akan dapat jawapan final answer, it's fine. Dengan syarat jalan kira mesti betul. And kalau awak stuck, awak tak boleh jawab soalan, you must find the number of moles first. So everything must go through the moles. Okay, kena lihat betul-betul information yang diberi dalam soalan. Okay, let's try a few example di mana I got example 1. In 14 gram of N2, I want you to calculate number of moles of molecule. Saya tertinggal perkataan of kat sini. And then number of molecules. Dan saya nak number of atoms. So, saya dah beri kepada awak molar mass untuk N2 adalah 28 gram per mole. So, how to calculate this? Based on the information given is only the mass for N2. So, mass di sini adalah 14 gram. So, how you want to do the first question? You have to calculate the number of moles. So, you got mass, you got molar mass. Automatically, you just divide the value based on this formula. Mass over molar mass. And put the value, make sure the mass is in gram. And your molar mass as given, you will have your number of mole is 0.50 mole. And what I'm going to emphasize here is when you put your calculation in subjective style, please put the subject at the front. So number of mole here, you can put as a subject, or maybe you tak nak tulis panjang, you boleh tulis mole of N2. So, mesti ada subject dan mesti ada unit dekat belakang. So that's how you want to answer to get the full mark. And please, saya harap awak takkan guna perkataan ataupun subject like this. Try to avoid that. As I mentioned before, and ini boleh jadi integer dekat bahagian empirical formula. So we want to try avoiding that in your answer scheme. Okay, next one. Let's get to example 1. Question number 2, Roman. You have to calculate the number of molecules. So, number of molecules, as usual, kena compare dengan awak punya Avogadro's constant. So, in this case, when you have the number of mole, so of course, your number of mole must be multiplied by Avogadro's constant. Sebab mol awak bukan 1 mol sekarang. Mol awak adalah 0.5 mol. Sebab tu awak akan darab dengan Avogadro's constant to get the number of molecules, which is 3.011 exponent 23 molecules. So that is for 0.5 mol. And next one, question number 3, I ask you number of atoms. So how you want to do that? In general, based on the question, you have one molecule of N2 where it contains 2 atoms of nitrogen. 2 atoms of nitrogen, it means that the value that you got here is for 0.50 mole. But I want the number of atoms, which means I must multiply the value with 2 for all atoms in one molecule of N2. So, the final conclusion that you can put is number of atoms is equal to 6.02 exponent 23 atoms. And please put the statement in terms of what for your answer at the end of the word. So, one more thing that you have to understand, put your answer at least in 2 significant figures or 4 decimal places. Okay, 2 significant figures is what I'm referring bila awak ada simbol exponent. So, boleh je tulis 3.01 exponent 23. For this case pun sama, awak boleh tulis 6.02 ataupun 6.0 exponent 23. Itu baru boleh buat 2 significant figures. Tapi kalau jawapan awak tak ada exponent, you don't have to put 2 significant figures. Awak kena buat 4 decimal places at least. Sebab kalau awak dah bunda awal-awal, you round off very early, your values will be out of the range for the final answer. So try to be careful about that. Okay, let's try second example. So for the second example, I want to calculate the number of H atom in 1 mole of NH3. So as I mentioned before, in this case, specifically for H atom. So, in 1 mole of NH3, I got 3 moles of H atom. Where did I get this one? Saya ada H3 kat sini. So, dia bermaksud 3 moles. And then, boleh tak saya calculate the number of moles sekarang untuk dapatkan number of atoms? So, saya boleh calculate sebab saya ada mole, saya ada Avogadro's constant. Dan apa yang saya nak adalah number of atoms. So this is what I want to find out. This is what I have, and this is also what I have, 3. Okay, so what you're gonna do, you will have this value where you calculate the final answer will be 1.806 exponent 24, dan term kita sekarang adalah number of H atoms, so you can put atoms or H atoms. So that's how you want to understand about this example too. Okay, next one, I give you one more example. Example 3, you have to calculate the number of bromide ions in 2 moles of CaBr2. So how to get this? Okay, kita keluarkan a few statement from the information given. For 1 mole of CaBr2, you got 2 moles of bromide ions. So, you got 2 moles of bromide ions from the formula Br2, which means 2 moles of bromide ion. And then, for 2 moles of CaBr2, contains 4 moles of bromide ion. Maknanya awak darab lagi 1 kali ganda. Sebab apa? I want for 2 moles. This is for 2 moles. Here. So, this is the moles that I'm going to use. And what I'm going to do now, I want to calculate the number of bromide ions. So, dalam example sebelum ni, saya dah tunjuk pun pasal ion. So, this is where it goes for one example, number of bromide ions. So, how to calculate? Number of bromide ion is your subject equals to, you got the number of mole, 4, times with Avogadro's constant. So, you will have your final answer is 2.408 exponent 24 ions. Dan term awak sekarang in terms of ions. Alright, so that's all for this video. So please try to complete this question to improve your understanding. Please do this and try to answer the question. I give you the final answer here. You can refer your calculation whether you get the correct final answer or not. So that's all for this video. We will continue the second part for the next video. That's all from me. Thank you.